Alright, this is Mr. Crozier. I want to help you and show you how to draw out these vectors on practice test 4. Number 1, an object is being pulled to the north with a force of 10. So we have obviously we have a bearing problem here. We want to keep track of everything. So we have north, east, south, west. And the first vector is to the north with 10. So I'm just going to go ahead and use one color here and draw this. And that vector is north. It's going straight that way. Then the next vector is to the south of 8. So I'm going to draw this, try and make it a little bit shorter, and that's 8. And then to the southeast with the fourth of 7. So that's out this direction, a little bit smaller of 7. Well, obviously, if we want to find the resultant, we just add them together. So it's vector A plus B plus C equals the resultant. But the key here is, what angles are they at? Well, northeast, southwest work, but your calculator does not recognize that. What your calculator recognizes is 0, 90, 180, 270. So the direction for vector A, which I'm calling north, is 90 degrees. Use that in your work. For vector B, which I'm going to call the south, well, your calculator is going to recognize it as 270. For the southeast one, your calculator could recognize it as negative 45 degrees because it's a drop of 45 degrees from 0. Use these angles with all of your work and you should be fine. Down here, 3 forces pull on an object. Now there's no mention of northeast, southwest. So when we set this up, we can go straight to 0, 90, 180, 270. There's no mention of northeast, southwest. There's no mention of bearings. So you can use that. And then just go ahead and put your magnitudes in there. I suggest you use a protractor. The first force is 75 pounds at 30 degrees. Well, 30 degrees is right there. And we're going to say this is about 75 pounds. The next one is at 45, 100. So 45 is here, and it's at, 45 is here at 100. Well, it has to be longer than that, so let's just make it out there, and that's 100. And the last one is 125 at 120. So if I put my protractor on here, here's 120, and I want it to be the longest. So here, and then the question is, well, find the resultant. Well, good. Where do these? Add them all up. Add them all up, and you'll have the resultant. And where do you think it's going to be? Well, to me, it looks like the strongest force is out here. So the answer is truly, go ahead and draw it for you. It's somewhere in this fashion, out that way. Don't know how far it goes, but it is towards that direction. All right, on the back, we have a wind speed problem here. Without the wind, we have a plane flying. So let's go ahead and draw this without the wind. And again, now we're dealing with bearings, and this is 0, 90, 180, 270. Northeast, southwest, going around the circle. All right, it's going at 148 degrees, so that means I'd go to 90 and go 58 more degrees, so it'd be down here. So the plane is flying down this way in some fashion, and I might mark that here. That's 58 degrees. And then now the wind blows, obviously. Well, this is 875. The wind blows to a bearing of 140, so now 140 is here, 100, 10, 20, 30, 40. It blows at 10 degrees back. So we're going to draw that angle somewhere in here. And now we have, and it's shorter because it's only 800. And this turn right here is only 50 degrees. And what's the vector of the wind? Well, that's the wind right there. It's that vector. You could draw it there if you wanted to, but it's that vector right there. And what are we going to do? The plane plus the wind equals the resultant. So if I take away the plane, the wind is equal to the resultant minus the plane. Go ahead and do that math and you'll be able to figure it out. be careful. Cannot use these numbers in your calculator. What was this, 148, 140? You cannot use those in your calculators. But you know what you could use? You could use these angles, -50 and -58, because your calculator will recognize a -50 drop from there and a -58 drop from there. All right, problem 4, vector A has a magnitude of 70. Well, right there's vector A, 70. Vectors A and B are added together. The resultant has a magnitude of 100, and there's a 20-degree gap between vector A and the resultant. So if this is A, the resultant's here at 20, it's going to look like that. What is this, 100? And if I want vector B, what's vector B look like? Well, vector B looks like that. If I want to draw it over there, that's vector B. Vector A and B go together to make the resultant. A plus B is the resultant. If I want B, I subtract the A, gone. B is equal to R minus A. Set up your work. Resultant minus A equals the B vector. And again, you put it all in here. Cosine, cosine, sine, sine will give you the components of that. All right, hope this helps you get started.